Good morning. My name is Justin, and I'm here with the PubLock team. And today, we're going to walk you through our senior design project, the PubLock, the public use bicycle lock system. Now, before we go into the actual project, I'd like to motivate the discussion a little bit by talking to you about the problem that we tried to solve with the PubLock. Now, back in September, we were looking into the problem of bike theft. And we looked at some Department of Public Safety data and found that there were 23 bikes stolen on Penn's campus in September. Now, if you assume an average price per bike and extrapolate the price out, you find that this is about $75,000 a year in bike thefts. Then we decided to look at the problem a little bit closer. And we found that 43% of those bikes were stolen due to incorrect usage of personal locks. So students would buy a lock for up to $100, lock their bike up incorrectly, and have their bike stolen anyway. So we thought, why not scrap the problem of personal locks altogether? Why not take away these systems that force you to trade off between mobility, the ability to bring your locks in, and security, how well you can lock your bike, and implement a system that would be public, more intuitive to use, without compromising on security. And with that, I introduce to you the PubLock and the rest of my team, Joe Polin, Joe Hill, and Alex Neier. And today, I'm going to walk you through where the PubLock could be useful in a public setting. Then, Joe Hill is going to walk you through our project goals, our solution, and our prototypes. Alex Neier is going to walk you through the user experience of the PubLock. And finally, Joe Polin is going to wrap it up with security and outreach. So where would the PubLock be useful? The first case we obviously looked at was Penn. The PubLock would be useful at Penn. They would be interested, potentially, in buying units of the PubLock and offering it as a free service to students and faculty. In return, Penn would be able to promote a green initiative, encourage bike riding, and reduce the amount of crime on campus. Additionally, the PubLock would be useful in municipalities like the city of Philadelphia and other communities, where we would be able to implement the PubLock and charge a usage fee or a monthly membership fee. Finally, bike share programs might be interested in purchasing the PubLock so that they can implement a more distributed system with less overhead. So instead of those bulky 50 bike racks that you see with typical of bike share programs, you could maybe have 5 to 10 per block and allow easier usage. So with that, knowing where the PubLock might be useful, I'm going to pass the floor off to Joe Hill, who's going to talk to you about our project goals.
Thank you, Justin. So, at the beginning of the year, we didn't just jump in head first. We decided that we wanted to set out some project goals for the end of the year. And those goals were threefold. One, we wanted to eliminate personal locks, so you didn't have to carry around your lock. Secondly, we wanted locking to be intuitive. It needed to be easy to learn and easy to use. And thirdly, it needed to be high security. Obviously, we're not going to make a bike lock that doesn't actually lock your bike. So, with those goals in mind, we came up with our solution, which is the PubLock. And as you can see, the design is simple but effective. There's a handle with a chain that comes out of a barrel, and it goes into the locking housing. And the whole unit retrofits to an existing bike rack via these coupling clamps that you can see here. So now I'm going to walk you through how to PubLock your bike. So imagine you're biking down to engineering, you're a little bit late for class, and all the racks are taken. So you see a PubLock at the end. You walk your bike up to it, nice and flush to the rack. You pull the handle through the frame, and you insert it through the spokes into the locking mechanism. Once it's in the locking mechanism, you take an RFID card, tap it, and it's locked. Now this is kind of cool because next year Penn will have RFID in all of their Penn cards, so it works well with that. And only you can unlock it once you lock it with an RFID. So now my lovely assistant, Joe here, will go through how it all works in motion. So he's going to walk the bike up to the lock, nice and flush with the rack, pull the handle through the frame, through the spokes, into the locking housing. And he takes it out of sleep mode, locks it, and then there you go, you're off to class. So he'll unlock it now so you can get the bike out of the way and see the whole PubLock still. Yeah, there you go, and off the bike goes. So our solution was developed mainly through prototyping. And it's pretty funny looking back on this, especially those handcuffs up at the top and seeing how far we've come. The progression of these is in a counterclockwise direction, and most of our prototyping was driven through user testing. So that helped us answer questions like, do we want RFID or Bluetooth? Where should the locking housing be in reference to the spout? And how should the chain track on the spout? And Alex is going to talk to you a little bit more about why we made the decisions we did with those choices.
Thanks, Joe. So the user experience from PubLock was one of the most important parts of the project. We wanted it to be intuitive to use, so we need to let customers through user testing in order to figure this out. One of the first things we wanted was it to be easy to use just when you walk up. When you use a U-lock, you have to position your body in awkward ways in order to get the U-lock around the bike properly, which you found a lot of users were having difficulty doing. So when you walk up to the PubLock, the handle's right at waist level, you can just grab it and pull it out. When you pull the chain out, you can pull it out horizontally. We found that through user testing, most users wanted to do this instead of pulling it out down vertically, so we changed our design to reflect this. Next, when you grab the handle, it was designed to be very comfortable in hand with ergonomic considerations, much better than a U-lock. And finally, when you enter the handle into the locking housing, as Joe said, it's directly behind the wheel, so you just put it right through the spokes into the locking housing. It's really easy. It's very difficult to position the bike wrong, so it's going to lock up perfectly every time. I mentioned the chain retraction. This is very important because we found that if the chain did not retract fully after each locking, or after each unlocking, it was hard to pull the bike up to the PubLock, and it didn't look very good. So we need the chain to retract fully after each unlocking, but we also need the user to be able to pull it out in order to lock their bike up. So there's a trade-off here. We analyzed a variety of elastic materials, based on force versus strain, creep, and fatigue, to make sure that after multiple loadings and unloadings, this would still perform the way we expected. And we actually selected the material, which you see in this red graph, which gave us an optimal trade-off. The material is actually an elastic material, similar to what you find in the waistband of underpants. But it works really well for us. We have an apparel configuration, and as you can see, pull it out really easily, it retracts really easily. So that was a great trade-off. Next, the electronics. So when you walk to the PubLock, you push the button to activate the electronics. A green LED surrounding them turns on, letting you know it is indeed active. You scan your RFID card, which oftentimes can be right through a wallet, so it's really easy to use, much easier than a key with a U-lock. We use this button and RFID combination to maximize power, to minimize power consumption. The PubLock is powered by a battery, and doing this allows us to put the electronics into sleep mode when not in use. We're also looking at extending the battery life further through the use of a solar panel, which would supplement our power greatly. We've also done some manufacturing analysis for this prototype. So based on a small batch, about 100 of these units with the current design, we estimate that the cost for manufacturing would be between $105 and $177 on the high end. This is only for manufacturing. It doesn't include any margins on top for a business. And if we were to go further forward with this and implement it, we would redesign it to take advantage of some manufacturing techniques that would decrease the cost significantly, we hope. With that, I'm going to turn it off to Joe Polin, who's going to one of the most important parts of the project, which is security.
Thank you, Alex. So at the end of the day, this is a bike lock. And it goes without saying that security is our #1 concern. We talked to the Department of Public Safety here at Penn, and they told us it's not about whether or not your lock can be broken, it's about how long and how much energy it takes to defeat it. So we wanted to be as good, if not better than, the top items on the market right now. To do that, we took a look at some of the ways that we thought thieves might try to defeat our lock. For example, we thought they might try to pry the whole tube off the frame. So we designed these half-inch thick steel couplings to make sure that nothing short of a pickup truck would be able to pull it off. The chain, which is the main locking member, is anchored to the bottom of the tube with a steel cable. So in case you were worried about trusting your bike to the strength of the underpants elastic, that steel cable becomes taut and prevents you from pulling the chain all the way out. The chain itself is designed to be bolt cutter resistant. After doing a little research, we found that bolt cutters tend to be the most common tool amongst bike thieves. Both the shape and the material of the chain is designed to be bolt cutter resistant. Of course, we didn't want to just take the website's word for this. So we headed over to your friendly neighborhood locksmith here in West Philly and had him try to break through our chain. He started with an angle grinder, which is kind of like a handheld saw, which will cut through just about anything. And sure enough, after clamping it down, he was able to cut through it after a little while. But you can see from how many sparks he generated, and trust me, it was very loud as well. We're not too worried about bike thieves carrying around angle grinders. We asked him to try using his 4-foot-long bolt cutters on a chain, and he said, absolutely not. My bolt cutters will break before I get through that chain. That was good enough for us. So now I'm going to take you through the guts of our locking mechanism. Here we've stripped away the housing, the chain, the bike rack, everything, so you can see what's going on inside. You can see the handle, where it will be once it's fully inserted, and that little upside-down L piece is the locking bit. Once the user taps their RFID, the locking bit rotates into a slot in the handle. At this point, if you try to pull out the handle, you won't be able to. Although you can't see it here, that locking bit is also reinforced by the housing itself. A big question we had to answer was, what happens if we lose power? What happens if the battery runs out or some system malfunction cuts off power to the PubLock? We thought, well, first of all, we might be able to avoid the situation altogether by having some sort of sensor that detects when a battery is running low and doesn't let users use a PubLock that's running low on battery. But that's not going to prevent all cases of this happening. So we designed it such that if power is cut off to the PubLock, then your bike remains locked. It's not just up for grabs. Until you either restore power or have someone come and manually open the PubLock using special tools on our tamper-proof bolts, your bike will remain safe and locked. From the outset, we interacted with a lot of groups both here at Penn and around Philadelphia. As Justin said, one of our goals was to design this to be implemented at Penn, so we spoke to a number of stakeholders here. We also worked with the Detkin IP Clinic at Penn Law, and they helped us author a provisional patent, which we filed a little over a week ago. I would like to thank everyone who helped us make this possible. A number of you are in this room right now, so I'd like to let you know how much we appreciate your help and support. We hope you enjoyed learning about the PubLock and that you're as excited about it as we are. I would now like to open up the floor for any questions.
If this became popular, it seems to me you would have a problem with multiple users. Have you thought about making it such that multiple users could connect to the same basic assembly?
So right now it's designed so that one bike can be locked to one PubLock. Actually, when we talked to facilities, they did express interest in having two in the same unit, but we've designed it so that two PubLocks can go in the same rack, so that you can lock two bikes to it just like you can now. But that is something we have considered.
Okay, so that might be next year's.
Yes.
Yes.
Here's why you have it tied to the front wheel, where the rear wheel and the other one is vulnerable. I was, that would be more security than the front wheel.
So we looked into common locking practices before we actually started designing the PubLock, and we found that the majority of people only lock the frame and the front wheel, and that there's only a very small percentage of the population who will actually lock the back wheel as well. So we thought that we wouldn't be cutting out that much of the market by only locking the frame and the front wheel, because we're still matching at least the security of the U-lock, if not beating it with the system we have.
The front wheel is much more susceptible to theft. The back wheel, you have to pry open the frame, so it's a lot harder to get.
Yes.
For those of us that haven't been riding a bike in a while, do you have comparison with some of the existing locking arrangement in the different places, Europe, for example, or see how this would provide a major advantage of security in addition to just a technological benefit?
We haven't specifically looked at Europe, but I mean, me and Joe studied abroad in Europe, so we've been there. I mean, I know in Amsterdam they use certain bike locks, which allow them to do it easier. I think the PubLock would be great there. I mean, they ride bikes so often, but they use mainly chain locks, U-locks, which are both things that we considered designing the PubLock and tried to make it better than those. I think we did.
How long does the battery last?
Currently, the battery should last about 10 days running, but that's without optimization. Like I said, we're not electrical engineers. We think we'd get a lot more out of the system if we were, or if we had one on our team. And the solar panel, our current draw is so low that a solar panel should be able to supplement it easily. Sure.
Can you monitor all those remotely? Do you have any sensors on it at all where you can kind of see what are being used and what happens with patients if they have?
Right, so we were considering different input methods. We ended up choosing RFID after asking a number of users who tried our prototype whether they preferred RFID or Bluetooth by using their phone. They preferred RFID, which is a little easier to implement maybe, but it did mean that we don't have cloud access. If we were to use Bluetooth instead, or in addition to, then we could connect to the cloud through users' phones, and then once you can do that, the opportunities are endless.
Good.
As a victim twice of bike theft, that I can very agree. I'm just curious, you had mentioned that one of the reasons you have developed this was because you thought that a lot of people were chaining their bikes wrong. Curious if you could expand more on that and how this solves that problem.
Well, you can, I mean, if you walk around campus, you'll see plenty of bikes that just lock the frame or just lock the front wheel. We actually were interviewed by the Philly Inquirer on Monday, and we walked the interviewer by the bikes, and he was so ecstatic because he was just finding bikes and like taking them out because they weren't locked at all, and he was like finding bikes like that. But the design of the PubLock is such that it would be very difficult for you to only lock up your front wheel, the frame. It's much more natural for you to just put it through the frame and through the front wheel. So that's how we try and mitigate that.
That's all we have time for. Thank you
All
very
right.
much.
Thank you very much.
Thank you.
Thank you.